Alright, so hey guys, welcome back to another video. So in this video I'll be going over, um, I'll probably break this up into 3 videos actually. So I'll be going over the problems in week 1 of the June Leetcoding challenge. Um, I didn't do them on the day that they were like assigned because I've been pretty busy with finals. School is a thing, yeah, kind of sucks, but yeah. So I just had some time to work on them today. It took me about 50 minutes to finish all 3. They weren't too bad. So yeah, I'll be going over the solutions to all of them, but in this video I'll be going over max area of the island. So yeah, so this problem, in this problem you're essentially given a 2D array, and each square in it is either a 0 or 1. And so essentially you're supposed to find the largest block of ones. So it's pretty easy to see visually, right? This little L is like a block of ones, this is a block of ones, but this little Y, this little 4 shape is the largest block. And a block can only be connected directly vertically or horizontally and not diagonally like you see here. So yeah, I can just draw out the explanation for the solution for this problem. So this problem is pretty much a classic example of flood fill. So essentially, this is the idea. So we have this array of ones and zeros, right? So what we can do is we can just go through each spot in the array, like this spot, this spot, this spot, and at every spot we check if it's a 1, right? Because if it's a 1, that means we've detected an island. So because these islands are just blocks of ones, right? So once we have an island, we essentially start. I think it's the reason why it's called flood filled, because it's similar to a flood filling a room or something like that. So as soon as we detect a 1, we want to check its adjacent neighbors sideways, not diagonally, because you can only connect sideways because the diagonal doesn't work. So we just check its sideways neighbors to see if there's another 1 here, and if there's a 1 in any of these, we'll basically flood into this room, and we will expand from this room as well. So let's just say, well, this is obviously out of bounds, right? So there won't be a 1 here. So let's just say we discover a 1 here. Then we'll also want to flood fill starting from this point as well, and add it on. So then we'll basically grow our chain of ones. So if we find 1, we'll check. Let's say we find this guy and this guy. We'll add this guy and this guy to a stack of points that we're gonna visit, and we're gonna visit this and then flood fill from this as well. And the two main things to remember here while flood filling is you want to keep track of where you've been so far, as to not go back and infinitely count your little island, because you can only grow to a place where you haven't seen before. And the other thing to remember is that if you want to visit both this node and this node, when you're starting from this, you want to add both of these to the okay, let me explain this better. So when you discover 2 1s next to this one, and let's just say this is a 1 as well, let's just say you choose to explore this one first, you'll of course check and add this one. But when you explore this one, it's important not to add this one as well. So when you're adding a new node, a new point to this little group of ones that you're finding, you need to add it right away to your visited set, as to not visit it here, then visit it here and double count. You just want to avoid double counting or counting infinitely in this group. So those are the 2 most important things. And yeah, so that's pretty much it. So once you start off at 1 point, you will add all the points next to it, which are a 1, and then you want to visit all those points that you added, right? So let's just say we added these two to like a little list of points that we need to visit. We can just go through the list of stuff we need to visit, right? And if we go to one and we discover more guys, we can just add them to our list. So we'll have a list that constantly is telling us like, hey, you need to keep on visiting this to see if you can expand in any direction. And we'll also have like a set to keep track of all the points that we visited as to not double count or go back into a place we've already explored. So yeah, so that's just the theory behind the problem. Let's get into the implementation. Just a disclaimer, my implementation is not the prettiest because I was just kind of rushing through this, and I just wrote whatever came to mind first, so it's not that clean. But essentially, I made a point class which stores a location. So this is like a row and a column inside of our matrix, and just generic stuff here. Since we're using this in a set, because we're keeping a set of visitor points, you just have to override the hash code and equals method of your class. So that's what I did here. So of course, this is just a generic equals method. If the other object is an instance of it, you just want to cast it and then check if their row and column values are equal. And yeah, hash code, I just convert this to a string and return that hash code. It's a bit lazy, but it works. And the reason why we need to override hash code and equals is because if we don't, our set won't work correctly, because our set won't know how to hash and check for equality, so we won't be able to use like contains and stuff like that properly. And so when our method is called with a matrix here, we will create a new set of visited points, since we've obviously never visited any points yet. Well, this is going to be our counter of our current maximum island size. And then we'll go through each point inside of the grid, which is what these for loops do. It's just a simple nested for loop. And then, yeah, this part is not that efficient, but it works. So essentially the idea is we'll just make a new point here, and if we've never visited it, so it's not part of any known island, and it is an island because it has a value of 1, then we'll essentially start flood filling from that point. So we'll make a stack of nodes, stack of points to visit. We'll add our current point into it and add our current point to the visited collection. And so while we have more like points to visit, we'll take that guy, increment our size, because the size will represent the size of this new island that we found. And this essentially just checks if we can go upward 1. So if we can go upward, like it's not an array out of bounds, and the upward is still part of the island, and the point above our current point has not been visited yet, then we know we want to visit that because that's like a part of our island, right? So we will just push that into our list of points to visit and add that to our visited set, and repeat that with all the 4 other directions. And that way, after our while loop is done, we will have effectively found this contiguous block of 1s, right? Sorry, like that, because it's pretty much doing exactly what our algorithm outlined earlier is. It's just kind of growing this little thing, like flooding in the space, right, of 1s. And since we've been incrementing size every time we pop one of the points out of visit, size will essentially represent how many 1s we found starting from this guy. So we start from this guy, and then we add these nodes to the ones we want to visit, and then we visit these nodes, and then we check if any of their neighbors we should visit, and etc., right? And obviously this one won't be added because this one's already visited, but we will add this one because it's a 1 and we haven't visited it yet. And because we add it to the visited right away when we push it into the list of nodes to visit, when we start from here and we explore here, we will add this one to our list of to visit, but we'll also add it to visited. So when we visit this guy, we won't add this guy again because we know, like, we already visited this, right? So that just avoids any double counting, and after this while loop breaks out, we'd have found the size of this island that we kind of started from this point up here, and we'll just take the maximum of the current area and the island we just found, and we'll return the maximum. And conveniently, maximum starts at 0, so if you notice in their problem statement, if there are no islands, return 0. And yeah, an island is a group of ones, right? So yeah, so basically we'll end up returning 0 in the case that we never find any islands. And in the case that we do, it'll just be the size of the biggest island. So yeah, we'll submit this. As for the runtime of this, this is probably just O of it's an n by n matrix, so it's O of n by n because we're essentially visiting all the points inside this matrix at most once. Because when we find a group of ones, we'll immediately add all those points in that group to our visited set. So if we start expanding our island from this node, when we get to this node, we know, like, we already found the island that this node is a part of, so we'll never need to explore that part as well. So at most, we'll just be checking each location in the matrix once. So that gives us n by n runtime. And yeah, so it's accepted, and yeah, that's about it for the video. Thanks for watching. I'll see you guys later with the next problem of week 1.